Hello guys, welcome back. Today in this video we'll be looking at a Python library that is NumPy. So before going to NumPy, if you have not watched my previous lectures about Python, please do check the previous videos where we have learned required concepts of Python for AIML. So after completing that, you can come back to this video so that we'll continue with NumPy. So let's begin. Make sure you have your notebook and pen and your laptop or computer on so that we'll understand NumPy theoretically as well as practically. We shall do many of the code for our practice and so that we'll understand NumPy more better. So let's begin. Basically, what is NumPy? I have been telling that NumPy is a library of Python. What is that library? Why do we use NumPy? Basically, a library is a collection of pre-written code that help us to do task easily without writing everything from scratch. As I've given already about cooking example in the previous video, right? So instead of doing everything from scratch, you go and get the masala powder from the store so that you use in your cooking so that it will be easy and simple, very convenient, right? So library is also that which is already having a pre-written code in it. So when pre-written code is already present, you're just using for your use wherever it is required, you use that, right? So that is a library. So among that we have a NumPy as a library in Python. So what is this library NumPy do? NumPy stands for numerical Python, which means the name is only telling that numerical, it is doing something numerically, it is performing some operations on numbers, numericals, right? So that is what it is, numerical Python. So this is a library used for faster numerical computation, which means it is used for fast numerical and mathematical operation. If you have to multiply, if you have to divide, if you have to do some large math operation, you can do using NumPy in few seconds, not in within fraction of seconds. That is what the advantage of NumPy we have. It provides support for multi-dimensional arrays. You also know about multiplying arrays, right? If there is two array given, you multiply, you add, you divide. So all those things you have learned in your PU time, I mean in your 11th and 12th. So during that time you have learnt about doing arrays, matrices, everything, performing the operation on those arrays and matrices, right? So it will support for that operations and it is a foundation for AI ML data science libraries. Okay, we have seen about list, tuples and set in the previous video, right? I have explained you what is list. List is something which is consisting of different items, different elements in it, right? So I had given you an example about the shopping bag where you put everything whichever you want, and even if you want, you can replace, you can change, you can perform those operations. So list is also similar to NumPy. We used to store the elements required. We can perform the operations as shown in the previous video. Then what is the difference between NumPy and list? That is what the main question is. We'll be going step by step everything. We'll see what is NumPy, what makes NumPy different from list, everything. So basically, as I said, why NumPy is needed, because Python lists are very slow for large numerical data. These lists cannot perform a huge operations on any number, and NumPy uses optimized C and C++ internally. Yes, NumPy is a Python library, but NumPy is actually made of C and C++ internally. So this requires less memory compared to Python list and performs operation much faster. What is the core idea of NumPy is it works with the homogeneous data, which means a same data type. If I have a list, I mean NumPy, where it array, for example, if I have an array, that array consists of only single data type. For example, if I have a array of only integer, this array will only should have integer values. It cannot have float, it cannot have string. And data stored is in contiguous memory locations and enables vectorized operation. We'll be looking at what is vectorization in the later part of the video, and also it improves CPU sash efficiency, which means the efficiency, the storage, whatever NumPy uses, right? It is very minimal and it is very efficient. So what is ND array? ND array is the core data structure of NumPy. So we have a data structure in NumPy which is called as ND array. I'll show you what is this while coding, and it stores data in n dimension. For example, if we have a variable a can store any type. Like if it is, if I assign an integer, it can store an integer. So even ND array is also some data structure where we are storing n dimension. It might be 1D array, 2D array, 3D array, any multi-dimensional array can be stored. And all elements must be of same data type. As mentioned, every element inside a NumPy should be same data type. Enables fast mathematical computation, which is already known. Now, the dimensions of NumPy arrays. As I said, the arrays can be either 1D, 2D, 3D. So, used in videos, images, and deep learning. Yeah. Let us look at it one by one, the dimensions. Okay. So whenever you have to use NumPy, the very first important thing is you need to import the library. So therefore we use, I'll just zoom this so that everything is clear. Yeah. So import NumPy as NP. So NP is something we usually derive. It's like a standard thing we do. Like for Pandas we do PD, for NumPy we do NP, for Seaborn we do SNS. So it can be anything, but still we prefer NP. Okay, so import NumPy as NP. This is how we import the NumPy. Whenever you have to use NumPy, without this statement you cannot perform anything. So very major thing is you have to import NumPy first. Then later you can do any operations. First I'll show you how do we declare a array. I mean the NumPy array. So I'll take the variable arr array, and we will make sure that which is equal to np dot array. This is like kind of a function where we use it for creating an array in NumPy. And we open the bracket, we open a square bracket again, and we will store any number of elements. So after that you will just close it, and then if you print, this is a array. Array. Fine. So in real life example, if I have to give student marks in one subject stored efficiently, you can store like marks, numbers, anything can be stored. This is about NumPy, importing the NumPy and using the NumPy array. This is how we declare. Got it? Now we'll see the dimensions. When you see this, you can see it is a 1D array, right? It is a 1D array. So what is 1D array? 1D array is something which is only having one row. One row. This is 1D array. Basic. Fine. If you have to print this, you can also do that. Print arr dot ndim. This is n dimension. So if you run this, you will see it is 1. Right? This is a 1D array. Now let us look at 2D array. I'll just make sure this variable is named as array1 so that you will not get confused between array 1D and 2D. And now let us declare a 2D array. Let's do a 2D array. A 2D array is nothing but a matrix, guys. Simple. Okay, so array2, I'll take it as arr2 is equal to np dot array. This is must. Whenever you declare a array, you have to use this function. What do? You open the bracket and then a square bracket, two square brackets, and you will add the elements. You will close one square bracket, again comma, you will open other one, 4 5 6, again you will close this and close this, and later with a bracket. Fine. This is a 2D array. 2D. Fine. Later you can print ARR2, and also you can print the dimension. Simple. Change the name and let's run this. See, this is a matrix. This is a 2D array, not a matrix. Yes, it is a 2D array and the dimension is also given as 2. Next, what is 3D? Can you tell 3D is when you write the other box, that is another inside a square bracket? Is this 3D by any chance? And close this. Let us print it again. It has to give 3 if it is 3D. Okay, let's run this. Still is it 2? Yes, it is a 2D array. Any number of square brackets, any number of values if you write inside this, it will be 2D array. Then what is 3D array? 3D arrays, which is, okay, 2D is array which is having two axes. Okay, one is row, other one is column. But the 3D array should have, that is rows, columns, and the depth, that is length, breadth, height. That is what we call it as 3D, right? So when you have to write a 3D array, how will you write it? We can't write at least like this. So 3D arrays are those which is a combination of two 2D arrays. Did you get that? Combination of 2D array is called as 3D array. For example, if I take ARR3 and is equal to np dot array, this is must as mentioned. And now what you will do, you will make sure you have 3 brackets, 1 2 3, close the bracket, comma, 4 5 6, close the bracket, again close the bracket. So this is one 2D array, and if you take the same array and you just add it here, so this is a combination. This is one 2D array and this is one 2D array, and you just close it with one more bracket and this bracket. And now if we print, let's just copy this. And if you print this and check the dimension, let us see what is the answer. See, combination of two 2D array and the dimension is 3. This is the dimensions, multi-dimensional arrays. Yeah. And the next topic is array properties. So the properties are n dimension, that what we look now, number of dimension 1D, 2D, 3D, and the shape, that is the structure of the array, and third is size, the total number of elements present in it, and the D type, that is data type of data stored. Let us see how does this work. Now let's consider this 2D array. I'll take the, let it be here, and now I'll make sure that I'll print. Okay, I'll take this for your better understanding, otherwise you'll be like, where did this come from? So we'll take a 2D array and then we will print array2 dot shape. That's what the shape, that is the structure. And then we'll print array2 dot size. We'll see what is the size, and we will print array2 dot D type, that is the data type. And if you run this, the shape is 3 is to 3, right? It is 3 rows and 3 columns, 3 into 3, and the size is, the number of elements are 9, and the data type is integer. This is the properties. Fine. And our next topic is NumPy versus Python list. I've already explained you about this briefly, but let us go into it, deep into it, and let us see the difference between NumPy and Python. Okay. So first we had seen already what is list. List is something which can store a data types, mixed data types, that is different data types. We had seen the example, we had declared a strings, and between the strings we had also declared the integer, and it was able to print that. So it can have different data types, it can store different data types, whereas in NumPy it will store only same type of data type, only same data type can be stored in NumPy. And NumPy supports vectorized operations, yes, we'll see to it. And lists are slower for computation. For any mathematical operation, lists are very slow, whereas Python supports element wise operation. Let us see an example that how slow is list when compared to NumPy. Okay, we'll take an example, I'll show you, so that with time we'll check. Okay, so that you get the difference between list and the NumPy. Now I'll take a list, I'll declare it as lst, and this is a list, right? This is a list. And now I'll have a NumPy, that is array np dot array, and I'll declare same, or we'll take some other values inside a square bracket, it has to be. So this is a NumPy array. And if you have to perform functions, print lst into 2 and print array into 2. Fine, both are doing same thing. See, here list is performing concatenation when you write it as list into 2, that is 1 2 3 into 1 2 3, whereas this array is actually performing, that is 5 2s are 10, 6 2s are 12, and 7 2s are 14. And we will see one more example, where one more very important example, so that you get the difference. Fine, I'll import time, because I'll show you the difference between the time of list and Python, NumPy, so that you get the clarity. And I'll declare a variable called size, and let the size be some value, like we'll take 10 lakh. This underscore is nothing but you're representing a comma, like we write 10,000. So instead of writing comma, this is error in Python, but to differentiate we can use underscore. Fine. So this is some size I'm taking, and now let us see the list. That is list is equal to, sorry, we can't take list because that is something built in. We'll take plist, okay, Python list, or we'll take the full name. Okay, Python list, and we'll make sure that list of range, the size, which this size will be taking, size, and close the bracket, and we'll start the time. Time is equal to time into time. This is a function where that is why we are importing this. Fine, and we'll perform the operation that list will perform a square root. Okay, list squared is equals to, we can write x power 2 for x in Python list. We will close it. and then we'll end the time. That is, we'll declare it with end is equal to time into time, and we'll print it. Okay, print Python list time, where it is end minus start. Okay, this is start, this is end. So when you subtract end minus start, you get the total time, right? So we'll do that, and these seconds inside double quotes. So this was list, and now we'll do NumPy arrays. That is NP array is equal to NP dot array. We'll pass this Python list. Same. Okay. Again, we'll have the start time because we need to calculate start time also. And later, we'll square this also. Array, sorry, array squared is equal to NumPy array power 2. This is for squaring, and again you can end the time and print it. So here it is NumPy array, and it is again start time, end time. So let us see the magic now. See, the Python list time is about 0.105 seconds, whereas the NumPy array time is 0.0022, which is very least. If you take even a huge number like this, you'll see the difference. It will take some time, but see the difference. See, the Python list is taking a time around 0.8 second, whereas the NumPy is taking 0.018 seconds. You can see the difference, which is almost like 8 to 7 to 8 times or even more. So this is how NumPy is so fast, and list is very slow in computation. And even the memory usage also, list take lot, whereas NumPy take very less. You can also check that by importing sys and we'll print it, print Python list size. We'll take the size, that is sys dot get size of, this is a function which we are using for Python list. We'll pass this Python list for getting the size into length of Python size. So it is like length into the storage. Fine. And for array, same way, print NumPy size. We'll take that np array dot n bytes. This will give us the storage. And now let's run this. Oh my god, look at the difference. The list size is about this number and the NumPy size is this. You can see there are a lot of difference between both the size. So this is how a list and NumPy has differences in both, where NumPy is very fast, use less storage. This is one of the example where you can understand it more better. Our next topic is creating NumPy arrays. We have few functions to create arrays. First is array, that is that we use np.array. So we'll create a array from the list, and if we use zeros, create an array filled only with zeros, and if you use ones, it will create array filled with ones, and arrange and linspace, it creates the sequences. Let us see all this one by one. So we have already seen creating the array. This is the array, and our second function was zeros. We can take zeros, that is arr is equal to np dot zeros, and if you pass this size like 3 comma 4 and print arr. Let's run this. See, 3 is to 4 and it is only filled with zeros. If you have to fill it with only ones, you can use a function ones instead of zeros. You can remove this and you can write ones. If you run, it is only filled with 1. And for full, you can use full. That is, if you want to write arr is equal to np dot full, and you will pass 2 comma 3 and close it, comma 5 and close it, and then you print arr. See, if you do this, you can fill it with any number, like 5 you can change it to 8, 8 you can change it to 16, 16. This is how you do use full operation. And then to arrange, you can use arrange function, like instead of this you write arrange, and you arrange from, for example, if I take 1 comma 20 comma 2 with 2 increments, let us see why there is a error. Arrange, it is only 1. See, you get 1 to 20 with 2 increment. And if you use linspace for even arrangement, same way you'll do. You'll take this linspace and you can change it like to 4, 5. Okay, let's take it 5. So this is how evenly it is dividing the number from 1 to 20. Next is indexing and slicing. Indexing is used to access specific data. For example, if you have an array, you have to access any particular index, you use indexing. Supports positive and negative indexing, used to extract subarrays, that is slicing, very useful in data analysis. Let us see what is indexing and slicing. Now let us take an array, and then if I have to print only the particular index, for example, I'll take only array of 0, that is I want the first element, so it prints 1. So it is printing 1.0, that is in, like, it is printing in form of uh, float. And you can use it even in 2D array, for example, like close. For example, if you have to access 1 comma 1, why there is a error? Okay, wait. Oh, we have to do it without comma. The mistake is here, 1. It is array 1. See, 1 comma 1 was 8. This is how we do it for 2D array. And for slicing, you can take it from, like, from a range. For example, if you have to take from 2 to 6 in the previous array which we had taken, or let me just show you that. For example, I'll just take it, come back to 1D array only again. And if I have to show only from 1 to 3 and 1 2 3 and close this bracket. See, this is how it is. Again with the error in name, we have to write it array 1. See, so if I have to slice it from 0 to 3, that is 0, 1, 2, 3, but 3, 4, that is this index is not coming, only this 3 are being printed over here. This is slicing. And if you want, you can do this also from like empty, that is with square brackets empty, and if you print till 4 for example, it will start from 0 to 4. Array 1, see 0, that is 1 till this index it will do. You can do the same thing this side also, like 2, if you make it empty, it will print from 3 to the last index 5. This is indexing and slicing. And the next topic is mathematical operation. Mathematical operation, we have already seen you can perform any mathematical operation. We had looked into squaring, you can add, you can subtract, you can divide, you can multiply. So every mathematical operations can be performed, like addition, subtractions, and you don't need any loops. If you use arrays in list, for example, if you use list, if you have to perform any operation, you need to do for loop, because in our previous example we saw when I did square into 2, it didn't perform the operation, instead it duplicated 1 2 3. Why? Because we didn't use for loop there. Therefore it didn't give us the correct answer, because in a conditional, that is in traditional way, we use for loops to perform any operations, but in numpy we don't need any for loop to perform any operations. That is how it is, and faster than the traditional python operation. And the next topic is our statistical functions, that is statistical functions which are mean, median, mode, that is max, min, sum, and standard deviation. Median and mode is not given, but I just gave you the example. So when you have to get any arrays mean, or if you have to find out maximum for minimum, and if you have to take sum of all the elements, you can do, and if you have to calculate the standard deviation, you can do that. Let us see a small example for this. Let me consider a variable called marks. Marks is equal to np dot array. I'll declare the marks like 78, 90, 87, 91, 98, 96, 73. So some marks are being declared. And if you have to perform this operation, you have to use that function like np.mean, and you will pass marks inside it, and when you print it, it will print the mean value. So the mean value for all these marks is 85.833. Same way you can perform sum. Here we will perform max, we can perform min, and then we can perform sum, and for standard deviation we'll perform STB. See, this is mean, this is max. Among this, the maximum element is 96 and the least value is 73, and the sum of all this is 515, and the standard deviation is 7.9. So these are the operations, that is statistical operations. And the next topic is reshaping. That is, reshape is used to change the shape of the array. Like, that is, a reshape changes structure but not the data, which means if you have an array which is 1D, you can convert it into 2D array. Data is not getting changed, only the shape of the array is getting changed. Use in ML and image processing helps organize data efficiently. Let us look into an example. We'll take this marks only, we'll convert it into a 2D array. We'll just print marks dot reshape 2, we'll reshape it to 2 comma 3. Let us see whether can this performed, and let's run this. See, 2 is to 3, that is 78, 90, 87, 91, 96 and 70. This is how you can reshape it from 1D array to 2D array. And the next topic is broadcasting. What is broadcasting? Before seeing what is broadcasting, I'll just give you a small example. For example, if you have two arrays, one array is 1D array, the other array is 2D array. And if you have such different size of array or different shape of array, you cannot perform any operations on this because two different things and you cannot do anything. This broadcasting will allow operation on array of different shape. If it is 1D array, you can perform operation with 2D array. Smaller array is stretched logically, no extra memory is used and makes code clean and efficient. That's all. That is, NumPy applies operations automatically on arrays of different size. Let us look at an example. See, we'll take this marks only, we'll perform operation on this. That is, I'll add five. For example, in exam there was some wrong in there was some question given extra out of syllabus, and I have to give 5 marks grace to everyone. So if I have to provide them 5 marks as a grace, I need to add 5, right? For the complete array, for this complete array I need to add 5. So how can I perform is print marks plus 5. So when I do this, see, every marks is increased with value 5. You cannot do this with list. This is how you do broadcast. This is nothing but broadcasting. You can add 1D array and 2D array. We had already have this array 1 and array 2, right? See, the array 1 is 1D array and array 2 is 2D array. And now if I have to print that, that is print ARR1 plus ARR2. It will perform the operation. Why? We have to rerun this. Okay, let's take this. Let's just copy this. So this is 1D array. And I'll take 2D array. And I'll just delete this cell. So this is a 1D array where we have only 1D array elements, and here it is 2D, and we shall run this. Operands could not be broadcast together with shape. Yeah, the shape matters. If you have to take 3, see, the shape is, I mean, the size is something which you have to look into. The shape can be anything because here the shape is 1D and here the shape is 2D. But the size, the elements, it has to be same. That is 1, 2, 3 and 1, 2, 3. So then only it can perform. If we take it 7, that means the 4 elements, it will give us the error. You can't do with different size, you have to do it with same size, but still it performs the operation on different shape of arrays. This is called broadcasting. And the earlier of the lecture I said about NumPy can also perform the vectorization. Vectorization means performing operations on entire array at once without explicit Python loops. That's what we did here. Even we can perform the square also. For example, if I take SQ is equal to ARR1 and the square of 2. And if I print SQ, it will give us the squared answer. For 1, 2, 3, it will give 1, 4, 9. So this is vectorization. Here also what we did was vectorization. That's all. Simple, right? Now we'll look into the next topic, random numbers in NumPy. So this random numbers is a function where you can use rand so that you can generate a random numbers for testing, for training, because it generates some random numbers. It's not specific, it can be any numbers. So random numbers in NumPy is used to generate sample data. If you have to perform anything, you can generate a sample data instead of typing it. Important for simulations, help test ML models, and common in training algorithms. So to test, to train, we use this random in NumPy. You can just print np.random.rand with like 2 comma 2 or something. You can try this out. This is your homework. Okay. And our next topic is NumPy in machine learning. NumPy in machine learning is something where in ML is built on actually vectors, matrices, linear algebra, right? So NumPy provides faster matrix operation and dot products for it. That is used for matrix and vector operation, supports linear algebra function, backbone of Pandas and Scikit-Learn, essential for AI and deep learning. So if you have to perform any operation, any math operation, it can be performed very easily. Guys, one thing is, imagine NumPy as your spreadsheet, your Excel sheet. Okay, you have the table and you enter the data, it performs the operations. Like same way, NumPy is also an Excel sheet of Python where we used to perform operation. Numerical computation is performed using NumPy. And we had reached the conclusion, that is NumPy makes Python powerful for numbers, which does not, the other programming language doesn't have this library, and essential for AI and data science. For data science, it's very important, and it's faster, it's efficient, it's reliable, and first step towards ML mastery. That's all. This is all about NumPy. I hope you understood what is NumPy. We had seen the examples of NumPy. We have also understood some real life examples regarding like metaphor for NumPy. Everything is covered in this lecture about regarding NumPy. So if you have any queries, any doubts regarding NumPy, please do comment. And you also make research, go for the official documentation of NumPy, check what are things can be still present, like some of the built-in functions I might have missed in this lecture. You can go, you can check it out, and I have given you the homework to perform the random numbers. Also check that, you do that. That's all guys, this is all about NumPy. Thank you.